This video is on solid revolution and the shell method. And here I have this yellow region right here, which is the graph of x equal to negative y minus 1 squared plus 9. And so I'm going to revolve this yellow region right here about the line y equal to 5. And then I want to find the solid of revolution using the shell method. So here's the yellow region again, which is the graph of x equal to g of y equal to negative y minus 1 squared plus 9. And here's the line y equal to 5. And then we're going to revolve it about the line y equal to 5. And so here's the solid of revolution. And so when we revolve this yellow region right here, then this is the solid that we will get. And notice that the solid of revolution that we want does not include this part right here. And so to find the volume of the solid of revolution, what I'm going to do is I'm going to fill the solid of revolution with shells or cylindrical shells like this. And so I'm going to fill it up with 8 shells and then calculate the volume of each shell. And then that will give us an approximation for the volume of the solid of revolutions that we want. And so here are the calculations for the 8 shells. And so for the 8 shells, the volumes of the 8 shells is 570.21. But this is still only an approximation. And so if we want the exact answer of the solid of revolution, then we have to fill it up with an infinite number of shells. And so here's the what an ith shell looks like. And so this is one of the shell. And so the shell, it has an inner radius and an outer radius, and right in the middle right here, this is called the average radius. And the distance from here to here will be y sub I star. And therefore the distance from here to here, which is the average radius, will be 5 minus y sub I star. The height for this shell right here will be the distance from the y-axis up to the graph, this graph right here. And this graph is the graph of g of y equal to negative y minus 1 squared plus 9. And so to get the height with this shell, then we need g of y sub I star, because right here this is y sub I star. And so the distance from here to the graph will be g of y sub I star, and that will give us the height for this shell. And now let's find the volume of this ith shell right here. And so the average radius once again will be 5 minus y sub I star. That's the distance from here to here. And then the height of the ith shell will be g of y sub I star, but g of y sub I star is negative y sub I star minus 1 squared plus 9. And then all shells will have the same thickness, and so let's call it delta y. And therefore the volume of the ith cylindrical shell is 2 pi times the average radius times the height times the thickness. So we get 2 pi times 5 minus y sub I star times negative y sub I star minus 1 squared plus 9. And then the thickness is delta y. And so this is the volume of this ith shell. And so to get, if we have n number of shells, then here's the volume of n shells. This is shell number 1, shell number 2 in the nth shell. This is the volumes of n shells. And so if we want the exact volume, then we need to allow n to run to infinity. And for an infinite number of shells, then this is how we would write it. And so all of this right here, if we simplify it, it will come out to be, here's the 2 pi, and then we get y sub I star to the third minus 7 y sub I star squared plus 2 times y sub I star, and then plus 40. And then allowing n to run to infinity, and if this limit here exists, then we define it as the integral from 0 to 4. 0 to 4. If we look back at the original region right here, this is the original region right here, and then from here to here is 0 to 4. So that's why the integral here is 0 to 4. And then the integral for y to the third is y to the fourth dividing by 4. And then for 7y squared is 7y to the third over 3. And here we get y squared. And here we get 40y. Evaluating from 0 to 4, then we get 544 pi over 3, which is approximately 569.67 for the volume. And then if we compare it to the A shells that I calculated earlier, when I filled this solid of revolution with A shells, the volumes of the A shells was 570.21. And here's the volume of an infinite number of shells. It's 569.67. And we can see that they're very close. And that's the end of the video.